Hi everyone and welcome to part 1 of this video series on life sciences, paper 1, November 2017. Now you'll notice that in this section of this video series we're going to be dealing with multiple choices with and as well as the other various terminologies. Now, as you all know, I'm not gonna dwell much on the, as you all know, this is a 150 paper, both papers, and you both know the sections that this paper comprises of. Without any waste of time, let's get into it. There is section A, question 1. Various options are provided as possible answers to the following questions. Choose the answer and write down the letter A to D next to the question number 1.1.1 to 1.1.10. And the answer book, for example, as given, as indicated over there. Now, guys, it is very much important. It is of utmost importance, to follow, the strict examples that you are each given to. Each and every question has got its own examples that has to be followed thereof. Now let's get into the questions without any waste of time. 1.1.1, the part of the brain that is responsible for higher processes. Now guys, I hope you've done this section well enough, and you understand it, the section on the central nervous system and the peripheral nervous system. Now I'm gonna go through each and every option and tell you why it is not correct for your own understanding. Now, is it the cerebellum? If you remember the functions of the cerebellum, the cerebellum is not involved in higher thoughts and processes. It is involved in balance, and coordination. It is not involved in higher thoughts and processes. So that is why it is not one of the, let's scratch it out, it is not one of the solutions. Guys, that there is one possible solution for the multiple choices. Hence, you guys in grade 12, you don't have what we call negative marking, because you only have, out of those 4 options, now the chances that you're gonna be correct is 25% in each and every question. In 25% of every of the chances, you're gonna be correct or even wrong. So now let's look at option number B. Option B, is it the medulla oblongata? No, it cannot be the medulla oblongata. The medulla oblongata is it is involved in other processes, such as the coordination of, it is involved in like thirst, those things, hunger, so it is involved in those processes, like the sympathetic nervous system and those things. Is it the hypothalamus? No, it is not the hypothalamus. Do you even do the hypothalamus in your level? You just have to know it. You just have to spot it if you are given it on a diagram. You don't go deeper into the hypothalamus. Now we are only left with one option. which means that is our answer. That is our answer. There is D. That is the cerebrum. Now, guys, the cerebrum is, it contributes to much of the brain mass. Now, it is responsible for, all those higher thoughts and processes. It is responsible for, sensation, for motor, for sensation and motor responses. Now, when you think of moving, of lessening a movement in your arm, that is processed. I know that it goes through different pathways, but it is coordinated by the cerebrum. The cerebrum has got different sections, different gyrus. I'm not going to, you'll bear with me, guys. I'm a medical student, so I have forgotten the level of which you guys have to, know these things. So, but then I'll just, for your own understanding and for your own interest, I'll just give you all the things that I know, not per se, but for your own understanding and for your interest. Now, there is the cerebrum. Now, let's move on to the next question. 1.1.2, the central nervous system is made up of the central nervous system. The central nervous system. Guys, before you even attempt the question, just already answer the question in your head. You know that the central nervous system is made up of the spinal cord as well as the brain. It comprises of those things, of those two things. So let's just go through all those options. It is made up of the cranial and the spinal nerves. That is the peripheral nervous system. That is the definition of the peripheral nervous system. The cranial nerves, some of the spinal nerves. We've got 12 different cranial nerves. We've got cranial nerve number 1 up to cranial nerve number 12. For your own interest as well, you know that the cranial nerve number 1 is your it is your, what is it again? I think it's your let me remember well. Is it your olfactory nerve that is responsible for smell and all those things? So your cranial nerve number 2, it's connected to the eye. There is the optic nerve. Your cranial nerve number 3, your oculomotor nerve, your trochlear nerve, cranial nerve number 4, and etc. And the spinal nerves, we've got different spinal nerves. There's a lot of them. I'm not going to go to dwell much on them, but then that is the peripheral nervous system. It is outside the central nervous system. Now, option A is already out. Let's crash it out. Option B, is it made up of the brain and the spinal cord? Yes. Before we could even attempt the question, I told you that it was made up of the brain and the central nervous system. So it means our answer, before we even continue, our answer is B. Is it made up of the sympathetic and the parasympathetic nervous system? No, there is a different section of the. There is a sub section of the center of the peripheral nervous system. It is part of the peripheral nervous system. Now C is out, and then let's look into D. Let's see if why is D incorrect. Is it made up of the autonomic and the peripheral nervous system? Already, guys, you can see this is a big no. The central nervous system is not made up of the peripheral nervous system. Yes, it's also not made up of the autonomic system. The peripheral nervous system is made up of the autonomic, and it is the autonomic and the, is it? yeah, the autonomic and something like, I just forgot that other branch of the peripheral nervous system. So we now know that for 1.1.1 the correct answer is D, and for 1.1.2 the correct answer, it is also, no, it is B, it is not D, it is third one. And let's move on to the next question. Which one of the following is the dark colored layer of the eye? Now guys, the eye, which is rich in blood vessels. Let's read the question again. Which one of the following is the dark colored layer of the eye, which is rich in blood vessels? The dark colored layer, is it the conjunctiva? No, that is a big no. That one is not even colored, it is transparent. It is transparent. You know which one is it. I hope you know. It is, it is in front of the eyeball, everything that is in front of the eyeball, the cornea, the lens and everything. It protects you from different foreign substances that could potentially enter the orbit and harm it. Is it the sclera? No, that is not the sclera. The sclera is the whitish substance that covers the outer, that is the outer layer of the eyeball. It protects it. It protects the eyeball and gives its spherical, or rather its oval shape. That is not the sclera. Is it the cornea? No, the cornea is that transparent part of it is that transparent part of the sclera. It is an extension of the sclera that is transparent to allow light, the transmission of light into the eyeball. That is not the cornea. We've already ruled against these ones, so already we are left with one option, that is the choroid. Now guys, the choroid is that dark colored layer, and it consists of a lot of blood vessels. Now the reason it is dark is for it to be able to absorb the reflection of light. As light hits the back of the eyeball, the back of the eyeball is, it has got that layer that has got photoreceptors, the retina. So when light hits the retina, it reflects back. Now imagine we have so many reflections of, let me just draw it for you here. Now this is the back of the eye. You've got in a different color, of course, let's just choose blue. You've got light entering, it enters, then it reflects in different directions. It reflects and then it reflects. Imagine we've got different scattering of light inside the eye. Now there's going to be confusion. There's going to be, you're going to see a blurry object. Now the choroid is going to be, let's choose maybe brown or something. Now it's going to be here, that dark colored. Now it's going to absorb all these reflections of light and neutralize them, so that we have a clear image. That is the reason the choroid is dark colored. The reason is to absorb the scattering of light inside the eyeball. That was D. Correct answer was D. Which one of the following parts of the eye contains the photoreceptors? I've already answered that. I've already given it to you in the previous question. That is the retina. That is the retina. Without even attempting the other options, there is the retina. It consists of your photoreceptors. Remember, guys, we've got different receptors. We've got mechanoreceptors. We've got pressure receptors. Those, you've got photoreceptors, and there's different types of them depending on which part of the body you are at. You've got thermoreceptors and those ones. Now, is it option B? No. Actually, we know which option the answer is. So, but then let's just go through the other different options and see why they are not correct. Is it the iris? Now, the iris, yes, it of course it is colored. It is colored, but it doesn't mean it comprises of it contains photoreceptors. The iris is that colorful extension of the choroid. Is it? Yeah, I think it is that. It is an extension of the choroid of the ciliary body. So it is colored. It is coded for in your DNA. So if, for example, both your mother and your father have got brown eyes, have got a brown iris, then, for example, maybe you also gonna have a brown eye. If both your parents, your father has got blue eyes, your mother has got blue eyes, then the chances that you inherit blue eyes are very high. So it is coded for in the DNA. It is not, if it doesn't contain photoreceptors. Now, if we speak of photoreceptors, I hope you know what they are. They are the rods and the cones. They are connected to the nervous system. We have gone through that one. Now, does the sclera have photoreceptors? Hell no. A big no. It doesn't have photoreceptors. Remember, the sclera is that whitish outer layer of the eyeball, that keeps it in shape, that protects it, So is it the vitreous humor? The vitreous humor doesn't have it doesn't have photoreceptors. Remember, the vitreous humor is that liquid that also contribute to the shape of the eyeball. It's that liquid inside the eyeball. If, say, this is the eyeball, the vitreous humor is that liquid inside, that gives the eyeball its shape. You've also have got the aqueous humor. The aqueous humor that is in front of the eyeball. It is located between, I think it is, if I remember well, it is located between the cornea and the lens. It also contributes to the refraction of light as light enters the eyeball. I'm already giving you answers to the upcoming questions. Which structures in the eyes are responsible for the refraction of light? I've already given you some of the answers. In a way, these questions are connected. They are linked in a way. One, this question, there's vitreous humor there. They will, I've spoken of the aqueous humor and the link to refraction of light. Now, this question say asks us of the structures of the eye that are responsible for refraction of light. Is it the pupil? Now, do you know, I hope you guys know these different structures. You can spot them if given a diagram of the eye. Is it the pupil and the iris? I've already spoken. I've already talked about the iris. Is it the pupil? Do you guys know what the pupil is? The pupil is that opening, that allows the transmission of light into, it controls the amount of light that enters the eyeball. The eye is very sensitive to light. It is very sensitive to light, so the pupil controls the amount of light that enters. Obviously, in a dark environment, the pupil is going to be large. It's going to dilate enough to allow enough light to enter the eyeball. In an environment where there's a lot of light, where there's a lot of light energy, the pupil is going to constrict, to limit the amount of light entering the eyeball. Now that is the function of the pupil. It is that that small blackish structure that you see that is surrounded by the iris. That is the pupil. Now it is not these two are not connected to refraction of light. Now, is it the blind spot and the yellow spot? That is definitely no. Those are not connected to refraction of light. Is it the cornea and the lens? Yes, the cornea is responsible for the refraction of light. Remember, if this is our eyeball, this is our lens. Now we've got the cornea just in front of the lens. As light enters, it also let me just choose gray. It also play a role in refraction of light. It's going to refract, to bend. Refraction of light is bending of light. It's going to bend the light, to focus it, on. That is what is going to happen. That is what refraction is, to focus it on a certain point inside the eyeball. Obviously, it is going to focus it on that point, and I hope we both know what that point is. That is the yellow spot. That is the point that we've got high concentration of cones, high concentration of photoreceptors. So this one is already out. This one is already out. These two options are out. Now we have the cornea and the lens. As I've already indicated, that those two contribute to the fraction of light, to the bending of light. Now, is it the sclera and the suspensory ligament? No, the suspensory ligament is not even. It is not even connected. It is not even responsible. It is not even an option. Now the sclera blocks light in. The sclera is that wide, and I don't know how many times I'm saying it. I don't know. I've said it for so many times now. Now the sclera is that wide outer layer, that whitish outer layer of the eyeball that protects it, it keeps it into shape, is not connected to the refraction of light. Excuse me about that one. Let's move on to the next question. Question 1.1.6. Which one of the following occurs when you look up from reading a book on a clear, sunny day? When you look up from reading a book, imagine you are reading a book. Now, obviously, a book is less than 6 meters away from your point of view, from your eyes. Now just imagine what happens at the level of, for example, of the lens. Now, okay, I'll actually draw a diagram to indicate as I explain to you all the things that I'm going to be saying. Now, which one of the following occurs when you look up from reading a book on a clear, sunny day to focus on a mountain more than 100 meters away? Now, obviously, say this is the lens. I'm just going to draw in the lens there, and then you have your book there. There is your book. That is less than 6 meters away. The distance there is less than 6 meters. 6 meters away. Now, the lens is going to be to be structured in such a way that when you've got an object that is close by, now your lens bends it bends the light that radiates from it. It bends it too much. So to be able to do that, the lens has to be more convex. It has to be more convex. It has to, its curvature has to increase. Now, in this situation, the curvature of the eye, as you are reading a book that is close by, that is, you are looking at the book. Now, the curvature of the eye is maybe at its maximum. Now, you decide to look at an object as far as 100 meters away from you. That is the mountain. What do you think is going to happen? Now, the lens is going to flatten a little bit, to allow to allow the bending, the bending of the light that radiates from that object that is 100 meters away from you is not going to be, as intense as an object that is close by you. So to be able to do that, the lens is going to flatten out to allow less bending, less refraction of light. I hope I have already, given you an insight of what this question entails. Now, what happens? The radial muscle of the eye contracts. Now, if we think of it, the radial, let's look at it in cross, not in a cross section, in a longitudinal section. That is the radial muscles of the iris. Now, as you are focused on an object that is close by you, now the radial muscle is going to relax. We want to allow less light into your eyes, so your radial muscle is going to relax. Now, as you focus on an object that is as far as 100 meters away from you, your radial muscle is going, the opposite is true with what I've just said to you. When you are looking at an object close by you, we want to allow little light entering your eyes, because you are focusing on an object that is less than 6 meters away from you. There is you are going to do it with a little bit of some ease, because it's close by you. So as you focus on an object that is as far as 100 meters away from you, you are going to focus it with a little bit of some difficulty. Hence, we want to relax the radial muscles of the iris. To focus on that object, you want to dilate the pupil. So hence, what is going to happen is that we are going to relax the radial muscles of the iris to increase the size of the pupil. So already this one is out, because it speaks of the opposite. The radial muscles of the eye doesn't contract. It relaxes to allow dilation of the pupil. Now the pupil becomes dilated. I've already spoken about that. The pupil becomes dilated. That is very correct. But remember, we've only got one most correct answer. Yes, the pupil, as you focus on an object that is more than 100 meters away from, that is more than 6 meters away from it, it dilates. But remember, they've told us that that the environment is sunny. There's too much light. Now, in as much as we want to dilate the pupil, now we are going to limit it to not allow a lot of light entering, too much light entering your eyes. Now let's check other options and see if they are not the most. We are not going to have the most correct answer out of those ones. Now let's look at option number C. The ciliary muscles relax. Now if you picture it in your head, what happens when the ciliary muscles relax? When the ciliary muscles let loose, your suspensory ligaments are going to tighten up. They are going to become tight. So what happens when your suspensory ligaments become taut? They become tight. So they are going to pull away the lens, so hence flattening it out. So they are going to make the lens flat. As I've already in the first concept, I've spoken about at the level of the lens has to be flat, has to flatten out in order to allow less refraction of light, because you are now focusing on a far object. So this one is the most correct. Yes, the pupil becomes a little bit dilated, but that is not, in this instance, it is not what we need. We need a flattening out of the lens. Now, how does that occur? The ciliary muscles have to relax. Now, what happens when the ciliary muscles contract? The opposite happens when you are reading a book that is close enough. Then the ciliary muscles are going to contract, to allow the suspensory ligaments to be less tight, and increase the curvature of the lens. Now let's look at option number D. This one is out, and this one is out by virtue of C. It's out. Now the lens becomes more convex. That is the opposite of what we've just said. if the lens becomes more convex, it becomes more convex when you are reading a book, when you are looking at an object that is less than 6 meters away from you. So the lens becomes less convex. It doesn't become more convex when you are looking at an object that is as far as 100 meters away. Remember that we are moving from reading a book to looking at a mountain that is 100 meters away from you. So the lens, this one is already out. So we are going to be left with C, option C there. I hope, guys, my explanations are enough for your understanding. Let's move on to question 1.1.7. Now, which one of the following pathways represents a reflex arc? Guys, you know your reflex arc, and you know the definition of the reflex arc. And the reflex, that mechanism, the reflex, it functions in protecting us. For example, if for example, I accidentally put my finger on a hot object, or for example, if I pierce it accidentally with a pin, then that is where my reflex is going to come into play. I don't even think about it. Now it's going to happen automatically, because as we evolved, as Homo sapiens, as humans evolved, now those mechanisms, they evolved with us, to just they are there to protect us from danger. Now the pathway that a reflex follows is as follows. Is it A? Is it option A? Is it from a muscle, spinal cord to brain? Guys, I've told you, you don't even think about it. If the impulse goes to the brain, then your brain is going to process it. Then you are going to think about it. Now, this one occurs in a period of time that you don't even think about it. It doesn't even reach the brain. So option A is already out. Is it the effectors to the spinal cord to the receptor? Remember, the effector is what elicits the movement. If, for example, the effector could be the muscle. Now, does it move from the muscle? No, actually, it is the other way around. It is from the receptor to the spinal cord to the effector. Now, the receptor is what picks up that sensation, and then it travels to the spinal cord, then back to the effector. Now, this one, the reason is it's incorrect. It's because it's the other way around. Now, is it C? From the receptor to the spinal cord to the brain. This one is also out because it doesn't reach the brain. Now, is it the receptor to the spinal cord to the muscle? Yes. Now, in this option, they've removed the receptor. They've substituted the receptor the effector for the muscle. The muscle is an effector. It is what does the movement. If, for example, you accidentally put your hand on a hot substance, on a hot surface, then what is going to to pull away that hand, your muscles, your biceps brachia, your biceps and triceps, they are going to pull it away. So those muscles are your effector. They are what does the job. I hope you understand. Now 1.1.8, after exercising in a gymnasium, people often go into a steam room to relax their muscles. The average temperature in a steam room is 41 degrees Celsius and the humidity is between 80% and 100%. Now, which one of the following explains why people are advised not to stay in a steam room for more than 15 minutes? Now, increased sweating will cause overheating. Now, remember, guys, the temperature in the room is 41 degrees and the humidity is 80% to 100%. It's between 80% and 100%. Now, do you think with the amount of water vapor that is in the room, do you think you're going to sweat, or the opposite is going to occur? Now, do you think there's going to be evaporation? Remember, when you sweat, evaporation occurs, or do you think there's going to be condensation? Now, with the amount of water vapor inside the room, the opposite is going to occur. That is going to overpower sweating, evaporation. Remember, sweating contributes to cooling. When you sweat, your skin cools because of sweating, because of evaporation. Now, for evaporation to occur, you've got to absorb the heat, the energy from the environment. Hence, it results in cooling. Now, the opposite occurs when condensation happens. You have to give off that energy, that heat. Now, already A is out. Now, let's look at option B. Sweat will not evaporate, as I've already said, causing overheating. Yes, the reason sweat will not evaporate is because of this. There's a lot of water vapor in the room. So hence, condensation is going to overpower sweating. So it's going to overpower evaporation, and hence sweating will not occur. Now let's look at the other options and see if they are not more correct to that one. Now, vasoconstriction will lower sweating, will lower sweat production. Now remember, the temperature is 41 degrees Celsius, hence your temperature is going to increase. And in the first place, you are from a gymnasium. I mean, you are just from a gym. You were exercising and your temperature is very high. You are entering a room which has a temperature of 41 degrees Celsius. Then the mechanisms that controls heat, that the thermoregulatory mechanisms in your body, in your brain is going to coordinate those, for you to lose heat. Now, what happens is that what is going to happen is that the blood vessels at the surface at your skin, the blood vessels that takes blood to the skin, and they are going to vasodilate. They're going to vasodilate to allow more blood to reach the skin, for cooling, to radiate out a lot of heat. Now, let's look at this one. Vasoconstriction will lower sweat production. That is not the reason why we have low amount of sweat that is being produced. So, it is not vasoconstriction. Instead, it is vasodilation that is going to occur. But vasodilation results in more sweat being produced. But in this case, sweat is not going to be produced because of the humidity in the room. Now let's look at option this one is out already. Option D, heat receptors in the skin will be damaged. Now, at that temperature, at 41 degrees Celsius, do you think we're going to have the heat receptors being damaged? I don't think so. It is correct to some extent, but it is not the most correct. Remember, we need the most correct option here, which is B. Let's move on to the next question. 1.1.9. A tumor in the hypothalamus of the brain of a patient caused a condition called diabetes insipidus. Guys, diabetes insipidus is a condition in which you produce lots and lots of diluted urine. Now, below are some of the patient's symptoms. Dehydration. Now, the dehydration results from the fact that you lose a lot of water, a lot of liquid that is less concentrated with electrolytes. Now, we've got dehydration. We also have production of large quantities of dilute urine, as I've already explained to you. Which one of the following is the most likely effect of the tumor? The tumor in the hypothalamus. Is it increased secretion of TSH? Remember, TSH is your thyroid stimulating hormone. Now, what does the thyroid stimulating hormone has to do with the regulation of liquids? It has got nothing to do with that. So really, it is out. Now, ZB, decreased secretion of ADH. Remember, the functions of ADH is to increase the permeability of the collecting ducts. Now, when the permeability of the collecting ducts is increased, now we're going to have a lot of water being reabsorbed, being absorbed into the urinary tract. Now, hence, we're going to lose a lot of water. So I hope you guys understand. Decreased secretion of ADH. Now, decreased secretion of ADH, we are not going to have increased what I just said, permeability of the collecting ducts. Now, hence, we are not going to have more water being reabsorbed. We are not going to have water being reabsorbed. Then we are going to lose water because of that. Hence, we have more production of dilute urine because of that, what I've just said. I hope I've explained enough for your own understanding. Decreased secretion, the tumor causes a decrease in the secretion of ADH. Hence, we have this condition, diabetes insipidus. Now, let's look at the other options. Increased reabsorption of water in the kidneys. Increased reabsorption of water. Now, that occurs when you have ADH, when you have a lot of release or secretion of ADH. Now, in this case, we've got a tumor in the hypothalamus. Remember, the hypothalamus is linked to ADH. The hypothalamus produces ADH, and then it releases it into the posterior lobe of the pituitary gland and stores it there. Now, when we have a tumor in the hypothalamus, it maybe distorts the production of ADH. Now, when we have, in this case, we have in this option, we have increased reabsorption of water in the kidney, and that is controlled. That is elicited by much secretion of ADH. In this case, we don't have enough secretion of ADH, hence this option is out. Option D says increased permeability of the collecting ducts in the kidneys to water. Now that is the function of the ADH. Now we don't have a lot of ADH. We don't have enough ADH being produced by the hypothalamus as a result of this tumor. Now this one, they are all linked. Both this and this one, they are both linked. They are expressed differently but linked. So we are only left with that one as our most correct option. Now question 1.1.10 says contraceptive pills which prevent pregnancy are likely to contain. Now remember, to prevent pregnancy, we have to prevent what? We've got to prevent ovulation. We have to prevent excuse me about that. We have to prevent the development of the Graafian follicle. Now, how do we do that? How do we halt that process? We can halt that process by injecting maybe, or or taking progesterone as a pill, or ingesting it intravenously. Progesterone, remember that graph, it is like that, of progesterone. And then we've got those we've got in a different color. Let me just choose. We've got the graphs of FSH and LH here and LH here. Now, if you notice here, when there's a high concentration of progesterone, now both your FSH and your LH are low. Now it's because of the inhibitory effect of progesterone on LH and FSH, mostly on FSH. Now, if we don't have the follicle stimulating hormone, now we are going to have the Graafian follicle is not going to develop, and hence we are not going to have ovulation. Now, how are we going to have pregnancy when we don't have ovulation? Now, that is one way in which we can prevent pregnancy. Now let's look into our different options and see which one is the correct one. Now, option A, high levels of FSH and progesterone. That is very wrong because of FSH. Now, if we have FSH, then we are going to have ovulation, and subsequently we're going to have pregnancy if the ovum gets fertilized by a sperm. Now, that one is already out. It is already out. It is not FSH. High levels of luteinizing hormone and estrogen. Luteinizing hormone contributes to ovulation. That high LH surge that occurs just before ovulation. We are going to have a lot of LH that is going to be released by the Graafian follicle just before ovulation. That is what is going to contribute to ovulation. Now, it is not LH because of its effect on ovulation. Now, we don't want to have ovulation occurring, hence we don't need those hormones. Now, is it high levels of FSH only? Already it's out. We don't want FSH because we don't want ovulation. We don't want pregnancy. So it's already out as well. Now is it D, high levels of only progesterone? Like I've said, when we have high levels of progesterone, now we are going to inhibit FSH. Hence, we are going to we're going to hold the development of the Graafian follicle, and we're not going to have ovulation later on. I hope you guys understood. And if ever you've got questions, please post them in the comment section, so I'll answer you in the next video that I am going to upload shortly. I hope you guys understood this section of the multiple choice. In part 2 of this video series, I'm going to go through the terminologies, the different terminologies that you can come across. Thank you for your time.